Hi, this is a description of what you need to do in the lab for today. The lab is called Net Force Direction, and it's really just a tiny incremental step from the stuff we've been doing before. Um, the basic idea of what we're doing today is comes from Newton's second law, and Newton's second law says add up all the forces, all the force vectors, that's F net. That's equal to the mass times the acceleration vector. And since mass is always a positive number, think about what happens to the direction of a vector when you multiply it by a positive number. Uh, the the magnitude changes based on the size of the number you're multiplying by, but the direction always stays exactly the same. And so what that says is whatever you can figure out about the acceleration of a body, the direction of the net force is exactly the same as that. Okay, so the kind of stuff that you'll be doing for this lab is imagine we have an object that's moving along a path like this. Uh, okay, so here's an example. So imagine you have an object that's moving along a path like this, and let's say that it's speeding up. What can we say about the direction of the net force of the object when it's here? Okay, so how would we think through that? Well, the thought process is exactly the same as what we have been doing for accelerations. It's just that now, using this idea of Newton's second law, we know that the net force is that direction too. Um, so uh, the velocity is tangent to the path. So there's the direction of the velocity vector. It's speeding up. So that means that the part of the acceleration that's parallel to the velocity is in the same direction as the velocity. That's because it's speeding up. And I'm calling this a parallel instead of tangential acceleration because this isn't a circular motion, it's just a general motion. It's turning this way. So there's the perpendicular part of the acceleration. And based on those two, we know for the total acceleration, we're adding up something in this direction and something in this direction, but we don't know the magnitudes. And so that tells us that the total acceleration is somewhere in this range. Okay, so the total acceleration is that way, somewhere in that quadrant. And because of that, we know that the net force is acting somewhere in that range of directions. That doesn't tell us anything about the individual forces necessarily. Um, there could be 1,000 individual forces creating this net force, or there could just be one or two. We don't know. Um, but we do know that whatever forces are making up that net force, if you add them up, they add up to a force vector in this quadrant. Okay, so that's really all I have to say about this. Look at the lab, try to think through the problems, and let me know if you have questions.